Analysis of functions 1. Increase, decrease, and concavity. Interval of increasing, decreasing, and constant functions. From this graph, we can see that the function increasing on the interval negative infinity 0 and 2, 4, decreasing on the interval 0, 2, and constant on the interval 4, positive infinity. Definition 1. Let f be defined on an interval and let x1 and x2 denote points in that interval. The function increasing if fx1 less than fx2, decreasing if fx1 greater than fx2, constant if fx1 equal to fx2. Theorem 1. Let f be a function that is differentiable on the open interval AB. The function is increasing if f prime x greater than 0, decreasing if f prime x less than 0, constant if f prime x equal to 0. Critical number or critical point. Critical number, a value of x at which f prime x equal to 0. Critical point, the corresponding point on the graph of x. Example. Find the intervals of increasing, decreasing, and state all the critical points for this function. First step, find the critical numbers, let f prime x equal to 0, and solve for x. Second step, find the critical points, substitute the critical numbers into the function, and last step, find the interval of increasing and decreasing. By using sign analysis, the positive sign shows that the function increasing, and negative sign shows that the function decreasing. Concavity. Concave down. The curve lies below its tangent line, where tangent lines rotate clockwise so that their slope decrease. Concave up. The curve lies above its tangent line, where tangent lines rotate counterclockwise so that their slope increase. Definition 1. Let f be differentiable on the interval AB. Function is concave up if f prime is increasing and concave down if f prime is decreasing. Theorem 1. Function is concave up if f double prime x greater than 0 and concave down if f double prime x less than 0. Point of inflection. A point on the curve at which the curve changes from concave up to concave down or concave down to concave up. Here, find the value of x when f double prime x equal to 0 in order to determine an inflection point. Example. Find the inflection point for this function and the interval on which the function is concave up and concave down. First step, find the inflection point. Let f double prime x equal to 0 and then substitute the value of x into the function given. Next, find the interval of concave up and concave down. By using concavity test, the negative sign, which is f double prime x less than 0, shows that the function is concave down. The positive sign, which is f double prime x greater than 0, shows that the function is concave up.
Created using Powtoon.